Okay, once again as a reminder, a collection of sets is a partition of a big set X if the collection of sets is pairwise disjoint and its union is equal to X. So, you could simply take the entire set itself. That is called the trivial partition of X. You don't have to union a bunch of sets together. You just take that one set, and it's equal to X. Okay, the singleton partition is where you take the collection of all the individual elements. So we could write this, the singleton partition of X, we could say is the set of all sets with one element in them, such that that one element is an element of X. This is called the singleton partition. Take every single element by itself. Now the last one just says that for any subset A of X that's not empty, you can easily find a partition. Just take any subset. Make A, A is already a subset. I don't need squiggly brackets around it. And then I'm going to write down a complement. Everything that is not A. Okay, this is really like saying that X is the universal set. A is a subset. A complement would be everything that's not in A. So obviously they are disjoint, pairwise disjoint, because there's only two sets. If you're in A, you're not in not A. If you're in A, you're not in A complement. If you're in A complement, you're not in A. So they're disjoint, and if you union them together, you get X. So let's do one quick example. Find a partition of in the natural numbers. Remember what? The natural numbers. 1, 2, 3, ... That's just a reminder of what the natural numbers is. Well, there's an infinite number of partitions you could take. You could take the singleton partition. You could take the set with 1 in it, the set with 2 in it, the set with 3 in it, and so on, ... and get an infinite number of sets. A nice easy one would be, how can you partition the natural numbers into 2 nice sets? Well, we could take the evens and the odds. So one partition would be, remember, it's a collection of sets. So it's a set of sets. So I'll first do the odds. That's an infinite set. And the second set I'm going to do is the evens. This collection of 2 sets is a partition of the natural numbers.